roughness calculation using ImageJ software. Hello, you are welcome to Science Ray with Glory Valentine. Today, I will be answering a question from the video which I published titled How to Measure the Surface Roughness from Scanning Electron Microscopy Image using ImageJ software. The calculation is very easy and it doesn't take time. I believe it will be beneficial not only to the person that asks the question but also to researchers in biological sciences and physical science. Let's get started. When we talk about surface roughness, it is being characterized by the small protrusions or the peaks and holes valley on the surface in relation to a reference plane. In my previous video, I already gave out the link and the description how to download ImageJ, which is the VJ. In VJ, it has more functionality, more plugins than in ImageJ. So today, I'll add the plugins. When talking about ImageJ, the same group that created the software ImageJ also created the VJ. The only difference between the ImageJ and the VJ is that the VJ has added functionalities. It has a lot of collections of biological specific plugins already installed into it. So today I'll show how to add the plugins to your already existing application in order to calculate the roughness. Open to a browser and paste the plugin links. This link is in the description. Another thing you need to do is that if you are using Chrome, when you paste the link and enter, you will be able to get source file. Here are the plugins which you can use for the roughness calculation. So here we have the stuffjavj.java and here we have .class. In Chrome, I've tried to download but it didn't go through. But if you go for the .java, you will have the source code. What I did was I highlighted the source code, copy it. You can paste the source code in your favorite ASCII editor or word processing program as long as it can save file in ASCII format and must be saved in a file whose name ends with the .java extension. Then you must compile your program. The Java compiler will then translate the Java code into Java bytecode, which are components of a machine-level language for the Java virtual machine. So the Java bytecode will be interpreted and executed by the Java interpreter. When you compile the source code, the compiler creates a file with the .class extension in the same folder as the source file, and the compiler names the resulting .class file after the class defined in the source file. So another point is that Java source file are named for the class defined within. If you can see here, the source file, the name is here. So it will name it stuffjj.class. That was how I used the .class file and add to my plugin. The other method is really very simple. Don't use the Chrome, but use the Firefox browser. On a Firefox browser, paste the plugin link, enter, So here is the site and the free downloading plugins. The file that you need download here is the .class StuffSharJ .class to download and add to the plugins. So click on it and it will download. You save the file, then go to your download folder. Here it is. Click on the file, copy it, copy, go to where you have your ImageJ folder. Mine is in document. Here is my ImageJ folder. Double click on it. This is the extracted file. And here is the plugin which I copied and pasted the StuffSharJ.class, which will enable us to calculate for the roughness. Back, then double click on the program. Sometimes it might be as the application is running, it will give a pop-up. If it asks you to update files, if you click on yes, it will update automatically, or you can do it manually by going to help. Here is the toolbar, so you can update it manually by going to help. From help, you'll see update ImageJ. Click on it. You'll see here upgrade to this. Do you want to start the updater now? If you click OK, it will find updates plugins that have already been installed, and will also give you an option to go to the new update site and new plugins that you don't have, so that you update. Okay, so it's showing details now. It's updating my ImageJ file. Okay, so I have to go back and then click on the widget app again. Double click on the application for it to start. It has finished loading. It means open my file and plugins have been updated. When it finishes, if there are the ones you need to update, it will show and also show manage update all the files, so you can check the one which you need to update. From file, you will see open samples. There are a lot of samples here already installed, which you can work on it before you work on your images or image. So like this one, we have the fly brain. If you want to measure, you can measure on this. Or we have a lot of samples here. The fluorescent cell. This one shows the fluorescent cell. We have a lot which you can easily play with the files to know how to work with your own. You can, if you want to zoom in or zoom out, for zoom in, you can easily press Ctrl+ and it will become larger. Zoom in, Ctrl-. and it becomes smaller. But I will be working on my own sample. You can easily click on File, Open, or you pick and drop. But I will go through File, Open, and here it has opened. This is the image I want to work on. Open. Okay. Can easily close this one. Okay. So this happens to be my original, and I want to duplicate. I'll go to Image and then Control plus Shift plus D. Okay, the image has been duplicated. It looks very big. I want to create a space here so that I can easily work on it. So click on the image, Control plus minus, Control plus minus. Since this happens to be the image I want to work on, let me zoom a little so that it will be visible. First, I will filter this image in order to help remove the edge detection, background correction, noise, and the image enhancement. So I will go to Process, then Filters. Here happens to be a lot of filters, but I will choose median. Why I'm choosing median filter? You see here the radius is 2.0, is according to the grains here. So click OK. From here, you can see the difference between these two images. This is my original image. Let me zoom. And this happens to be the one I have filtered. You can see there is a difference between the image. Okay. So what I will do now, there are also other filtering which you can use. We have the smooth, and we also have the subtract background, but I prefer using the median filter. I prefer using the median filter as I did because it measures the exact value. It will not compute a different value and it will retain the data. Median peak will look at every pixel in this image and give a sharp image of it. That's why I choose the median filter. Second step, I have to set the scale. Go to Analyze, Set Scale. And if you see here, the known distance is 100 nanometer. So what I will write here is 100 nanometer is the units. Okay. So that's it. And since I want to measure the roughness, what I'll need to do is I will pick a line here and draw a straight line from one end to the other end. Go to Analyze, Surface Plot. And The next, go to image type. The image type, note it has to be 32-bit. Analyze, plot profile, and here it is. This happens to be a low resolution plot, so go to more and choose high resolution plot. Okay, so I have here my low resolution plot, and these happen to be the height. I can also reduce it, control plus minus to reduce it so that I will have a space to work on this graph. Now we need to calculate the roughness. Also, to calculate the roughness, we have to still go to image and then check the type. It has to be 32. Then go to plugin, and then you will see what you added into your plugins to calculate the roughness, which is J1Q. Click on it. Here you have to check the level surface, the local roughness analysis, perform gradient analysis. You have to check all these. And the sampling length was 100 nanometer. So click on OK. And you have all the roughness parameters. Here it is. Thank you for watching.